Hi, I'm Jason medal-katz with Autodesk, and we're here at GDC. This is the GDC kickoff party at the Autodesk Gallery, and we're going to do a little tour of our gallery space here. So this is the Shanghai Tower. This will be the second tallest building in the world when it's completed, done by the architects Gensler. And what's really interesting about this project is that they focused on performance design. So it wasn't the aesthetic of the building that drove the design, it was really the performance. One of the things they were trying to do was reduce wind load at the top of the building. And so they looked at a lot of different variations of the form and the taper as the building moves from bottom to top, and used a lot of different computer models and simulations to end up with this beautiful form, which at the end of the day reduces wind load by 24% at the top of the tower, and that reduces the steel cost by $50 million. So performance drove the design, but they ended up with something really beautiful as well. So this is a competition that Autodesk and CG Hub sponsored to create the Ultimate Warrior. And Jesse Sandifer created the Turtle Barbarian. So he used Autodesk Mudbox to come up with this really creepy creature that won the challenge, and then we 3D printed it, and you can check it out here in the gallery. This exhibit is all about designing things at the bio and nano scale. So we're doing a lot of work in synthetic biology, so everything from visualization to simulation. This is a simulation of self-assembled particles. So as we click on one of these shapes, we see these particles floating freely, and then as the temperature cools within the simulation, these objects know how to put themselves together. And self-assembly is a principle that's really well known in biology and in chemistry, and there are researchers working on how to leverage those self-assembling principles in larger scale, so at human scale, or even at nanoscale, to program DNA to create new life and new structures. Really, really interesting stuff. This is all about seeing, understanding, and designing for the invisible. So this is work done at the University of Oregon by Jessica Green and her team, and they are understanding the microbial environments that are inside of buildings. So they take samples from floors, seats, desks, walls, and understand the different microbial biomes that are present on different surfaces and in different room types. And what they're trying to understand is, how do we design buildings better to attract the biomes and the microbes that are beneficial to us, and how to repel the ones that are detrimental. So you may never look at your seat the same way again. So this is all about self-assembly and taking the principles that are found in biology and chemistry and applying them at a human scale. So we have these objects that just by providing some energy, they know how to put themselves together in exactly the right configuration. So once you have the right geometry and the traction built in, all you do is add energy and you come up with self-assembled structures. So this is research right now, but you can envision a time where astronauts can have self-assembled buildings in space, underwater. Imagine a time where you get your furniture from IKEA, and instead of you assembling it, it self-assembles itself. The Mercedes Biome is an amazing concept car. It is truly a concept for the future. It is grown from seeds in the Mercedes-Benz nursery. Each wheel is its own engine grown from its individual seed, and then the interior is a seed and the exterior is a seed. It runs off of sunlight. Its only byproduct is oxygen, so it's really great to see how Mercedes is really thinking far into the future about how cars might look and function way in the future. And a tool that we have today is Autodesk Showcase, and this is a tool that people use to visualize and better understand what their vehicles will look like, or really any product. So you can see that by moving the physical markers, it changes what's on screen. We can also do things like change the color just by setting this chip down. One thing to note is the reflections in the paint of the automobile. and those are rendering in real time. And that's the real magic of Autodesk Showcase, is that it handles massive data sets and is able to render that information very, very quickly and beautifully. So we changed the scene, the surrounding scene, and you see how the coloring of the car changes as well as the reflections. So a lot of fun here. This exhibit's all about computational design, new materials, and ultimately the aircraft of the future. So original research here is done by David Benjamin to understand new materials. He's using bacteria to manufacture new materials. And what he was looking for is the perfect combination of structure and transparency. So he used computational design to look at tens of thousands of options and came up with options that were maybe a little too flexible, a little too rigid, too much structure. And interestingly, this one is this sort of asymmetrical shape that has a really nice balance of structure and transparency. And independently, researchers at Airbus were working on the concept plane of the future. And they came up with very similar ideas, and now these two groups are working together to understand how we can create materials and create this aircraft of the future using these new materials. So this is the Autodesk Transportation Simulator, and I'm going to go ahead and start my drive here down the new Presidio Parkway here in San Francisco. And what's really cool about this transportation simulator is that the project team was able to use all the 3D design data that they're already using to design this project and bring it into this gaming engine so that we can experience this before it's ever built. So a transportation simulator like this, to build from scratch and to model this whole thing, would cost 10 or 20 times what it costs once you already have the designs in 3D and you can just port it into a gaming engine. So this becomes a lot of fun, really immersive environment here. I'm going to see how fast I can get going here, and it's a whole lot of fun, but you can also develop some very bad habits. Don't try that in the real world. So 3D printing is something that's really interesting. It's technology that's been around for a long time, but now it's really becoming democratized. It's becoming accessible for a lot of people. So these are MakerBot Replicator 2s. These are at a really reasonable price point. What we're printing out here are these creatures that were created in Autodesk 123D Creature for the iPad. You can create really crazy, fun creatures and then send them directly to a service bureau or print them out yourself on your own MakerBot. So a lot of fun, really accessible to people who are hobbyists or professionals as well. So this is our 3D photo booth. This is using Autodesk 123D Catch technology, which enables you to use 2D photographs to create 3D models. Now we have a number of cameras set up here just for convenience sake, but anyone can take a camera, any camera, your iPhone, your Android phone, or an SLR, and take photographs, a whole bunch of photographs of an object, submit them to our service that goes up into the cloud, and it renders this full 3D model of whatever object you want. So what we're doing here is capturing people's heads, so people could then print those out, create a bobblehead of themselves, or just have a nice 3D model of themselves. So this is something you can try at home with 123D Catch from Autodesk, or come visit us in the gallery and try it out here. So we saw the desktop 3D printers earlier. This is an industrial strength 3D printer. This is from Objet. This one does multiple materials, so you can do 2 materials at a time, which is really nice because you can do things with maybe some transparency as well as some opaque objects. Really fine resolution on this printer, and you can also see some of the many things that have been created with 3D printers of various types, everything from gears to prototypes of objects to actually finished pieces of work.